Macmaths. Let's do some maths today. Okay, in this lesson, I am going to go through the Suvat equations. I'm just showing you the four equations that we're going to look at in this chapter. I'm going to explain what Suvat means. The chapter I'm going to actually go through in this series attached to lesson 3. Exercise, I think it's 9C and 9D. What they do is they look at two equations, they split them up, they look at two of the equations and they do some questions on them, and then the other two equations and do some questions on it. But I don't like that, because actually some of the questions that you can do in 9C are better having all four equations. So I'm going to go through all four equations with you, in this quick lesson. Okay, so why do we call them Suvat? Well, when I was at school, we didn't. This is a sort of a new thing. It's like one of those acronyms, like Sokoto, which I don't like either. I don't really like this. But anyway, S stands for displacement. So this is the displacement. To you, that's a posh word for it. It's the distance travelled. Okay, so it's displacement, the distance travelled, the distance from the starting position. Okay, got to be careful. There is a difference between the distance travelled and displacement. But I'll talk about that more when we come to it. U is the initial velocity. So initial speed. V is the velocity after a period of time. So A is acceleration, obviously. And T obviously is going to be time in these equations. Okay, the V and the T are connected, so if we're putting in 3 seconds into our equation, that's the velocity after 3 seconds. If we're putting 10, we're using T as 10, that's the velocity at 10 seconds. So those two are connected. So here we go. This is what we've been looking at. We've been looking at these velocity time graphs. You can see that this straight line here is something undergoing constant acceleration. In other words, the change of velocity with time. So after this particular time, it's gone from having this speed to having this speed, or this velocity to having this velocity. So the velocity is increased. At this point here, when t is equal to 0, when we start a simulation, that is the initial velocity. So it started off here. So this is our u. After a period of time, remember these two are linked, it's now reached this velocity. Okay, so what have we done so far? Well, we know from what we've done that the area underneath the graph is the distance travelled, the displacement. Okay, so if we use our formula for a trapezium, we can say that the area of the trapezium is equal to a half of A plus B times the height, isn't it? It comes from that. It comes from, let's just change that. Area is equal to a half of A plus B times the height. That is the two parallel sides times the distance between them. And our two parallel sides here on this trapezium is going to be u and is going to be v, isn't it? And the distance between them is the time. So if we change that, okay, we can look at the formula and say the distance travelled, the displacement, is going to be equal to u plus v divided by 2 times t. Okay, so that is our first equation. Written another way, a half of u plus v times t. So that's our first equation. That's the first Suvat equation. And again, don't look it up, or rely on, looking it up. Learn these equations, okay, so you can use them quicker. So that's the first one. The other one that we're going to look at that isn't in 9C is comes from looking at the acceleration here. Well, as you know, that the acceleration, okay, is the gradient of that line, isn't it? So from the gradient is the acceleration. Okay, so The gradient of the line, and again from from GCSE, the gradient m is equal to y over x, isn't it? So that's what we're going to use. Okay, so the acceleration is equal to, well, the y, this distance here, is v take away u, isn't it? That's that distance there, v minus u. Okay, so v take away u gives you that distance there. So the y is v minus u, and the bottom, of course, is the time to that point, so over t. So the acceleration is v minus u over t. Again, rearranging this, if we multiply both sides by t, okay, so times by t, and we get at is equal to v minus u. And then if we add u to both sides and just do it the other way around, you get v is equal to u plus at. And you'll be familiar with that formula because you will have had it in your physics GCSE as well. Okay, so v equals u plus at, another one of Newton's formulas, equations of motion. Okay, so 9C goes through those two equations and then it does an exercise, on those two equations. However, what I'm going to do is I'm going to combine them now. So for this one here, you can see that we can get rid of v here by substituting u plus at. So if we do that, we can go s is equal to a half of u plus, and the v is this u plus at times t. Okay, so then we can go that u is a half of, and then simplify this, 2u plus at times t. And then the next step here is to times all of this bracket by a half and times it by t. And when we times it by a half, we get a u and a half of that. And then when we times it by t, we get ut and plus a half a t squared. Now I did it all in one step, but if you're unsure, halve all of that and then times it by t. And that's our third equation. And we can also get, if we go back to this one, we can also get rid of t. Now, how can we do that? We've got, if I just take from this equation here, we've got a equals v minus u over t. Now, if I swap the a and the t around, t is obviously v minus u over a. Okay. Another way of writing that is to go that t is equal to 1 over a times v minus u. You can see multiplying that out gives you that. Now if we put that into here, so I take that, no I don't, I'm going to take that and I'm going to stick it into that one there. Okay. I'm going to stick it into that one there, and now I've got s is equal to a half of u plus v, I'm looking at that, and then times the t, which is all of this, which is 1 over a times v minus u. Okay, so I've just rearranged for t, and I've put it into there, and I've got that. Looks a bit of a mouthful, but we're going to tidy it up. If I combine the half and the 1 over a, that's 1 over 2a, just multiplying those two things together, times u plus v times v minus u. Now, very conveniently there, I could write that as v plus u, and you will recognise it, won't you? V plus u, v minus u. That, if we multiply it out, gives us a v squared minus u squared. The uv and the minus uv cancel each other out in the middle, so we end up with s is equal to 1 over 2a times v squared minus u squared. Now, we don't like this, so we times both sides by 2a. Okay, we get v squared minus u squared on its own, and we get this times 2a becomes 2as. And then again, just taking the u squared over, adding u squared to both sides, and we get v squared is equal to u squared plus 2as, and that's our other equation. So those are the four that we're going to use. 1 and 2, you can do all the questions from exercise 9c just using those two questions, but if you know those two, some of the questions are a little bit quicker and easier. You don't have to go through two routes, you can do it by a more direct route. And then 9d goes through 3 and 4, these two. Okay, so those are our four equations. Now before I leave you, I'm just going to rub those out, and I'm just going to show you how, before we start, how we do the questions. Okay, so we've got s equals a half of u plus v times t is 1. We've got s equals ut plus a half a t squared is another one. We've got v is equal to u plus at, and v squared equals u squared plus 2as. So those are our four equations, and you can solve all of the equations of motion questions using those four. I've used them a lot, they get me out of loads of scrapes. I tend not to use this one so much, but these three, you don't need that one. You can do it the maths by combination of these three. These are the three main ones that I use. Okay. When we talk about questions, can I say that what I want you to do is always draw a diagram. So it will talk about a particle or a car starting from a particular point A, now that, and travelling, to point B. So always start each question reading the question and draw yourself a diagram of that journey from A to B. Okay. At this point here, this is when we always start the simulation. So t is 0 at this point here, and this is the point where we have the initial velocity. Now sometimes that initial velocity, might be 5 meters per second or 10 meters per second. It's a bus that's passing, past a particular point. Sometimes it says start from rest, so it might be 0. At this point here, this is after a period of time. This is when we have the actual velocity. So the velocity that it reaches after a particular time. So this here, of course, is the displacement, the distance. If you've got that, you can write it in. It might be 10 meters, for instance. Sometimes they might tell you it takes 10 seconds, so or 15 seconds. So you can put 15 seconds in or write 15 seconds at the end. It's up to you. But get your diagram in before you start to solve the equation. Then you look at which bit of information you need and which bits of information you've got. And I suggest you write out Suvat, okay, and do yourself a little shopping list. Have you got the displacement? Have you got the initial velocity? Have you got, and which one is it you're trying to find? If you're trying to find the acceleration, put a question mark by it. Tick the other ones that you've got. You might have that one, and that one, okay? And then when you've got your shopping list, look at it, which one has those four in it, and it's this one, and this time I've got the velocity, I've got the initial velocity, I've got the acceleration, it's just the time that I need. So that would be the equation then you go for. So that is certainly one way of doing it, okay? And the one thing that I know, in fact I'm going to save that until we do acceleration and particles moving sort of vertically up and coming back down to Earth. In my next two lessons, or my next lesson depending on time, I'm going to go through key questions from 9c and 9d. Okay, you don't need to learn, I don't think, where these come from, but you do need to learn, learn the equations and get used to them. Okay. So s equals a half uv times t, s equals ut plus a half at squared, v equals u plus at, and v squared equals u squared plus 2as. They're very common. And one last thing that I'm going to say to you is also, when you're doing these equations, you need to pick a direction. So where that determines whether u, v and a are positive or negative, not so much A, I'll talk about that in a second. But for instance, if it's talking about a car going down a straight line, then in that direction, you probably pick that direction as positive. So U is a positive number and V is a positive number. Where you end up with a minus V, that means that it's travelling in the opposite direction. So plus and minus for U and V are talking about the direction that you are travelling in. For acceleration, that is whether you are speeding up or slowing down, because of course it's talking about the gradient, isn't it? Is the gradient positive or is it negative? So in the question, if it tells you that a car is decelerating, can't spell it at all, decelerating, I've deliberately spelled that wrong, I don't even know how to say spell decelerating. Accelerating is one. Oh, blimey, I've spelt it right. So if it says that a car is decelerating at 4 meters per second, decelerating, it means it's slowing down. It's got a negative slope. So your acceleration, your value of A, goes into your equation as -4. Okay, you put it in as -4. If it says it's accelerating at that speed, you put it in as a +4. So decelerating, it won't say the acceleration is -4 in a question. It will say it is decelerating. And likewise, if you get an answer where you've worked it says work out the acceleration, and it will say work out the acceleration. If it comes up with a negative, if you get a negative answer, that means your acceleration, is -5, for instance. You're saying the car is decelerating or the vehicle is decelerating. So just be aware of that. Okay. And I'm going to call that a day, and I'm going to do a 3A, maybe a 3B, going through key questions.